DAS Talk by Gamma, keeping you connected and protected.
Welcome to DAS Talk, the essential podcast on distributed antenna systems and in-building communication. Hosted by Peter, VP of Gamma, and Philip Nicholas. This Gamma Electronics series focuses on emergency response and safety. Join us as we navigate the challenges of building effective communication systems for North America's first responders. We delve into the advancements in emergency responder radio systems and the transformative impact on new technologies. Tune in for insightful discussions aimed at increasing knowledge and awareness in the DAS field. Whether you're a professional or an enthusiast, DAS Talk is your gateway to understanding the nexus of technology, safety, and communication.
Hey everyone, my name is Peter. I'm with Gamma. I'm here with Gil from Gamma as well, and Tom Cooper with Aari Wireless. As always, I'm super excited to be with you guys today, and thanks for tuning in to DAS Talk. Hopefully you enjoy our presentation today and our discussion. We're going to jump right into it and kind of allow Tom to introduce himself and tell us how he got to be the RF wireless expert he is today. Shoot, Tom.
Okay, well, thank you, Peter. I mean, that's a pretty strong word, so I'll try to live up to that a little bit, I guess. So I've been in the RF space for several years. I really started not in school, but I really started on the street. I was selling RF test equipment for about a dozen years, so that sort of gave me a good intro to all things RF. Everybody in my geographic area that needed equipment to generate a signal, measure signals, maintain equipment, install equipment, build radio networks, microwave networks, develop next generation products in their basement, maintenance, repairs, install, anything wireless. That was really how I got started. Cellular came along in the late 80s, which sort of revolutionized not just the wireless industry, but obviously the whole planet and how people live and things like that. So I was there before, and as cellular came out, after a dozen years in test equipment, I got into what we now call DAS, distributed antenna systems. Way back when, in the 90s, we just called it RF coverage enhancement. People didn't even often use words like wireless and things like that. So the industry is hugely evolved to where it is today in terms of magnitude, scope, especially in terms of the products, technology evolution, especially also in terms of business models, different people involved, different stakeholders, depending on the facility, depending on whether it's new construction. Obviously, with the past few decades, with the growth and expansion of ordinances across the country, starting in the west, spreading to the east. Things sort of got accelerated like a slingshot with 9/11 as far as the awareness and the need for in-building coverage, reliable coverage for the responders to go inside buildings. It's all about not just protecting the public, but also protecting the responders. And obviously, it's a very, very important industry. It's something very happy and proud of to be part of an industry that serves such a important purpose. So that's a little bit of my background. I've worked for a number of different DAS, BDA manufacturers over the years, something we can touch on a little bit in this talk. There's much, much more to DAS and in-building coverage and coverage reliability than just simple BDAs. The tools and techniques that evolved decades ago, in some cases, are still used today. In other cases, people have realized there's many more advanced technical solutions that can be used for better effect. And then we really get into important considerations like reliability and system availability and just the mission critical nature of it, combined with the more advanced technology. Things had to change. People just can't keep doing the same thing the same way without expecting to continue having yesterday's problems, which only magnify rapidly today because there's so many, many more buildings and so many more players in the industry. So that's a little bit of my bio. I've been doing it for some decades now, and I've seen a lot of the advances in the technology. I think today we're mostly going to focus on the technology. So I really appreciate and welcome the opportunity to connect with the good folks at Gamma and speak to your audience.
Oh, very cool. So you said You mentioned the word change, right? Because change can be a good thing and change can be a bad thing, right?
Yes.
So you said that the industry had changed. What are some of the most significant changes that you've seen, let's just say in the last, let's just say 20 years in the DAS world?
Oh, wow. Okay. So we got to keep this under an hour, right? Okay. So starting with the technology, the original coverage enhancement products, other than just, unidirectional things like voting receivers, let's just start with, say, bidirectional amplifiers, or BDAs for short. So the original BDAs were what we called broadband or band selective units. So for example, at 800 megahertz, they would amplify everything in the same RF band. At 800, that was 851 to 869 in the downlink. So really, you had a duplexer and an amplifier, and anything within the pass band would be amplified. That's also referred to today as a Class B BDA, or unchannelized in that sense. So that's really evolved over the decades. The first channelized BDAs that I was working with came out over 20 years ago. They were very expensive. They were individual channel modules with their own built-in power supplies. They were like an on-frequency repeater type of product. So in a bidirectional operation, you needed one of these devices per channel. Cutting to the chase, a 20-channel channelized system would have 40 of these devices, 20 in the uplink, 20 in the downlink, all the combining equipment. You're looking at hundreds of thousands of dollars. So in terms of change, it's not just the industry has changed as far as how people build the products. The components have changed. We now have DSP technology, FPGAs, where we can digitize in the RF domain, the channelization, where we used to have to literally grow crystal filters for in the past. So, with the advent of digital technology, filter technology, etc., that has sort of contributed, or has largely contributed, to the change in BDA type products as we've evolved from broadband to channelized. Well, why do you need channelized? Well, it's always been an FCC requirement that was sort of conveniently overlooked for many, many years, or not enforced, which allowed people to put in band selective devices. So in other words, you're not supposed to amplify or change anybody else's licensed spectrum. Well, a lot of that was going on because you pass everything in the pass band and the direction of the pickup antenna. So that's sort of a fundamental change that's occurred, going from broadband to narrowband technology. Again, some 25-ish years ago, people realized, some companies I've worked with closely in the past, that if you modulate a laser at RF, you basically turn a light source on and off like a strobe light, send a square wave pulse through a fiber at 865.6125, for example, cycles per second, and you have a laser detector at the other end. You can recreate the RF content and carry on the conversation. So you made a good point earlier. Well, change, and not everybody's open to change. And public safety is a very conservative, and rightly so, industry. So it's very important that when people do accept technology change, that they don't lose out in any sense on inherent reliability that they're used to. I remember early years, for example, at shows like IWCE, when we were demonstrating RF on fiber type products, and the people that would come up and say, "Wow, that's what is that? It doesn't make sense. Explain what you do," and then you'll just get a lecture from people about why it'll never work. And one of the main reasons why it'll never work is because they've never heard of it before. And if it works, they would have heard of it before because they've been doing it since the year dot. So then we go back the next year and we take a signal generator and a spectrum analyzer, and we actually show people that if you inject RF over here and then you convert it through the media converter and through the fiber in the other end, and you see on the spectrum analyzer, it really does work. And at that point, people just shake their head and say, well, they just walk away because they'd rather not believe it. So, that's decades ago. Fiber DAS has really become mainstream part of DAS in larger facilities and complex applications. There's many instances where you can't use just coax only BDAs, and there's many advantages of fiber BDAs. So those are a couple technical things. Getting back to the broadband thing, there's also other changes in the RF industry. Nextel came along, and then suddenly they're building high power towers everywhere. I was at a trade show once, APCO show. I had about 3 or 4 different people come up and say, wow, BDAs, they no longer work. Those things, they all started dying at the same time, which obviously makes no sense. So then you start thinking about it, and then you realize, now I know what's going on. It's called power robbing, because as Nextel built their networks, they were basically sending their signals through all these other broadband BDAs, and they were robbing all the power in the amplifier. So the PA, the power amp that was intended to provide coverage for the local sheriff in the courthouse, was being saturated with a Nextel IDEN system signal, and there's no power left there's no coverage anymore in the courthouse. There's lots of sort of things like that in the background of the technology that's also impacted the BDA. Channelization is one way to correct for that. Obviously, the FCC got Nextel to reband and move stuff around in the spectrum and stuff like that. Narrowbanding comes along. So you need more radios, you need more channel efficiency. So you split 25 kilohertz channels to 12 and a quarter. Well, obviously the DAS products have to accommodate that, especially when you're looking at channelized products. So those types of technologies or those types of happenings at the industry level, new bands come along, they have to be added to the DAS. We're looking at mission critical radio systems that are in the hundreds of millions of dollars. These are built with inherent reliability and redundancy in mind. So those types of performance attributes and features, redundancy, have to be incorporated into the DAS. You can't maintain the inherent network availability metrics by having just a simple, single point BDA. So lots and lots of advances, evolution in the industry, not the least of which more recently is the digitization. So the analog fiber links themselves have become digital in some instances. And with that transition, there's many more features, benefits, performance enhancements that can be brought into these large complex systems. So there's a lot more problem solving ability in today's modern technology. It's not just a box. Here's a box, figure it out, go design a system, find the best way to use the box. It's really, the approach is kind of swung around to the other side. What is the problem we are trying to solve here? What does this facility need? How many RF bands do you have? Do you need high power everywhere? Do you need all the bands everywhere? You can bring content aggregation. You can bring different RF services in from multiple different sites, either off the air with products which have built-in BDA functionality, or you can do direct connect systems. So there's tremendous flexibility. We do a lot of combined systems where you've got local RF content, similar to cellular, combined with off-air first responder frequencies. And if you're in the digital realm, it's easier to combine RF content from different bands, from different sources at the system level with packet data, CIPRI data. So lots and lots and lots of changes. So that's just sort of the tip of the iceberg.
Woo! That was a lot. That was awesome. Man, you're like an encyclopedia of RF and the DAS industry, Tom. It's amazing.
Some people just say I'm boring, but anyway, thanks.
No, I think it's fantastic because you hit on so many great things. And one thing I'd like to talk about a little bit, if possible, would be the redundancy aspect of it. So I think in most people in this industry and most BDA manufacturers have kind of a generic cookie cutter approach to most buildings when it comes to amplification of signal inside the building. I think you probably agree with me on that. So that's kind of how a lot of them take their approach to, and then they kind of compete and they sell red boxes, and then they sell, and then you got to buy coax cable, and then sometimes you have to do an active DAS and introduce some fiber into that. But it seems like Avari sets themselves apart from sort of the cookie cutter box manufacturers. What does Avari do that's different? You've alluded to that, but how do they accomplish that?
Okay, well, I guess there's two short answers. One is the approach, and the other is the technology. So, in terms of the approach, as you say, there's umpteen red boxes out there, and you go to trade shows and you see them on every table, and they all look the same. They're different sizes, and they got different heat sinks on the outside. Some of them do, single band cookie cutter 800 megahertz. Uh, Coax only. People are competing tightly into that space, maybe trying to squeeze a bit more RF gain out of it. 80 becomes 90 dB. You got to be careful with that. But essentially, it's a box business, and that opens the door to many types of players in the industry who have some expertise installing boxes. Our approach is different in that sense. We just look at it more from a solution standpoint. Buildings are similar, but they're all different and unique. Radio systems are similar, but they're all also different and unique. And every time you sort of complete a marriage of a radio system or systems with a building or buildings, you've got a unique set of challenges. And you have to have the tools to address that. So I guess the other thing in terms of the technology is we really look at it from toolbox analogy standpoint, just having the right tool for the job. So obviously there's a lot more smaller simple buildings that you might get by with just a smaller simple coax only BDA. If you look at the number of buildings versus vis-a-vis the size of buildings, they're inversely proportional. There's millions of single family dwellings. Then when you get up into the tens of thousands and hundreds of thousands of square feet, the number of buildings of that size decrease. There's only so many multi-million square foot facilities. There's a lot more to this industry though than just how big is your building, how many floors, how many square feet. There's many other layers and many other applications for DAS. It's not just an urban environment where you've got high-rise buildings or a million square foot warehouse. There's lots of other applications, which can be subway systems and airports and utilities and hydroelectric dams and nuclear power plants. A wastewater treatment plant is not something you'd find typically downtown for obvious reasons. Ditto with nuclear power plants. So there's big applications outside of cities for DAS that needs RF coverage. Some of them are very strategic. Some of them are, defense industry related. Some of them serve other purposes. They all have something in common, and that is buildings block radio signals. So getting back to and especially, in the downtown urbanscape now with tinted windows, it's not just like for decades we've been trying to overcome concrete and steel limitations, but buildings are, built today to keep the sunlight out, electromagnetic waves. Well, guess what? Radio waves are also electromagnetic waves that are blocked out in the same way. Getting back to your question, though, I guess what's different in how we approach it is we really focus on the larger and more complex and more demanding applications. We don't start by just like most people in the industry and companies I've worked with in the past. Well, here's a BDA. How do you expand on it in terms of features and functions and performance? You can put in a fiber optic link. You can increase the power. You can increase the gain. You can put in other features. I'll get back to your question on redundancy as well. So that's not where we're coming from. We don't just start with something and then try to evolve it into something that's quite different than what these things were designed for decades ago. We really start by looking at what are the challenges that are out there today and what does an end-to-end system really need to consist of. So in other words, the system solutions are designed for these applications in mind. We're not stretching something out of its comfort zone to address a unique need. We're going right against that direct need to begin with, or right with it. So that, lends itself to things that you mentioned, like redundancy. So people who make standard BDA or simple coax only BDAs, there isn't really a I mean, you can create a so-called standard redundancy option. Hey, just order two of them. But there's much more to it than that. When you put in redundancy in a fiber system, you can also bring into consideration a lot of other factors as well, such as fiber diversity. So if you have a device that's connected from a head end over here and from a different head end over there, whether they're different parts of the same building or different buildings on the same campus or different donor sites miles away, but by the time you actually connect the system, you can layer in diversity as well as redundancy, things that you can't do by just again trying to stretch a BDA into something that's really, really not. So I guess, sorry for such a long answer, we're coming at it from a different perspective. We're not just saying, here's a red box, it doesn't serve all the needs, how can I add more buttons and features and gain and etc. to it? We're really looking at it saying, no, here's a campus. A campus is a perfect talking point. So there's a lot of buzz, a lot of discussion in today's DAS industry about what people loosely refer to as noise and interference, also uh, referred to as too many BDAs. So if you have a campus, for example, in the past that years ago, somebody might put in for 20 buildings, 20 different BDAs, just have a different pickup antenna on every roof. Each of these buildings is an independent system spraying the donor site in the uplink with unwanted noise and cutting into the carrier noise and impacting, in many cases, the coverage footprint or causing bigger problems than that. So I think people are now of the collective conscience that there's a lot better way to do a multi-building facility like a campus. It can be manufacturing campus, it can be educational campus, it can be other specialized facilities. You don't need 20 pickup antennas. You don't need 20 off-air noise generators. If you have a properly designed, properly engineered, and deployed fiber optic radio network, there's tremendous performance enhancements in terms of noise, performance, C2N, but not only that, system maintainability. And then back to what you're asking about redundancy, things like that. So the technology really touches all these aspects at the same time. And then also, I use the word sometimes large and complex. That can get very quickly into a multi-building, multi-band type of consideration. And in many instances, it's not as simple. Even in fiber DAS, some people don't have a lot of familiarity with fiber DAS. People think of it as a wheel and a spoke, and you've got a head end in the middle of the wheel, and the spokes go out to the remote units. Well, that's fine if that's what you have as a simple architecture, but it's not always what you have. Sometimes to get to from A to C or D, you got to go through B and C or over here or back there. So you need a product that is flexible in terms of the architecture so you can cover multiple facilities and take most effective, efficient use out of existing fiber plant. And that can also be layered into redundancy consideration. So in other words, we're talking about a multi-tier DAS architecture, way beyond just a simple head end and remote one-to-one star architecture like in analog fiber DAS. So again, that answers sort of two questions. What's evolved and what do we do that's somewhat different?
So, Tom, let me ask you. I mean, we're talking about evolution. Do you think we'll move toward like having diversity, having redundancy in these systems, or do you think it's going to kind of stay, I don't know, in the status quo maybe, or what are your thoughts on that?
That's a really good question, Gil, because to me, there's so many different layers of that. So when you say, will it change? Well, it defines what is driving the it. If the primary driving force is codes and compliance and rule changes and what's written in the rule in an industry that's very competitive, where people are trying to come up with the lowest compliance solution, unless or until people look at things differently and include other parameters other than just local fire code and physicality and electrical and mechanical and alarm connectivity type of stuff. A lot of the projects that we touch are quite a bit different than, again, the cookie cutter public safety, ERCs type of stuff. Yes, the codes are there. Yes, people have to comply with the codes. Yes, the codes are well intended and well enforced and, well thought, but there's much more to it than just that. So a lot of these systems are inherently defined and designed with things like redundancy in mind. So we're not, in that sense, we're not going by what it says in the local code, which can be driving evolution, meaning the lowest compliant bid is going to get the job. That's more like de-evolution to me. But if you're looking at mission critical deployments, in a facility like a nuclear power plant or subway, these projects, there's kind of a different layer that's involved. It's not just the AHJ code compliance layer and the bidder layer where people are putting bids together with components from multiple sources and integrators, electrical contractors, and everybody's scrambling. No, these systems have another layer, and that is the consultant. So for something that is this mission critical, if not expensive and important, the facility owners, whether it's government or transit or etc., they are already expecting a higher degree of performance, which can only be met by a redundant system. So if you're talking about a requirement for 5 nines availability, reliability types of metrics, those specs are uh, inherent to it. They're not in the fire code, but it's not the fire code that's really, yeah, the fire code is, adjunct, but that's not what's really driving it. What's really driving it is reliability and performance, things like that, but not the lowest price. It's really, well, do I expect to see? I do see more in terms of change and evolution. I do see more bids calling for either reliability metrics or redundancy, but it's not as common as the majority of the industry, which still takes more of a cookie cutter, this is the way it is kind of approach. So there's so many layers to the discussion. I mean, you can look at things, for example, like fire ratings, 2-hour fire ratings. If you have a redundant architecture and the feed is coming from a completely different direction, do you still need a 2-hour rating on stuff when that whole direction is gone, so to speak? So people aren't thinking of rewriting the rules in that sense based on new technologies like what we're talking about now. The rules creation is done by the people who do a good job doing that and will continue to do so. I'm not saying it's a closed community,
Tom,
but
I gotta
yeah, sure.
jump in real quick because you brought up an interesting point, and it's come up multiple times in multiple meetings across the nation with multiple jurisdictions. I mean, it's always kind of brought up, and it has to do with what some people call it the riser, right?
Hmm.
Other people call it the backbone of a DAS system, right? And then
Yes.
this needs to be protected, and it needs 2-hour fire protection,
Yes.
right? So this is done through multiple ways. Either it's done through a shaft or a chase that is built that's got 2-hour fire ratings in it, and then if that's not available, they'll run very, very expensive cable, which is like a 2-hour fire rated cable. Now, the point you brought up I thought was really interesting and unique. So if you had a built-in redundancy into the system where, well, why would you need to have a 2-hour fire rated backbone if you had redundancy built in a different direction, where if this area went, well, then the other side of the building or the complex, had redundancy built in, so you wouldn't need it. So if that side went, then the other side could still send signal and receive signal. Is that what you're saying on the
Yeah,
redundancy
I'm
versus the 2-hour rating
yeah,
issue? Is that
I'm saying that is an example of evolving technology and trying to answer your question about will the rules change? Will it become more mainstream? So I'm only recalling one specific discussion with one particular AHJ about that. And I mean, they were just absolutely captivated hearing about a different way of looking at things. In the end, the short answer is, oh, well, the rules are the rules, and we'll just, stick with the rules. So, yeah, and yeah, go ahead. That's a wonderful idea. Put in the 2-hour rating. They wanted 2-hour rating on fiber, which would have meant in one case going back over a mile and lifting up the sidewalk and stuff like that. Because hey, the fiber that's there is no problem. But they were sort of going to the next level, saying, "Oh, well, that should really be a 2-hour fiber." And then you're into the construction industry and just mega costs. I think the essence of your question to me is perhaps should there be more dialogue with thought leadership who drive the industry to consider different types of things? It's not just the materials themselves. I mean, if you're looking at redundancy, it's not just you've got diversity and fiber coming from here. You've also got the head end. What if the site goes down? Some of the systems we do, you're picking up from particular donor site, but what happens if that system goes off the air? Maybe there's a lightning strike. You can't be in the building and say, "Oh, sorry, I can't communicate because lightning hit the tower." It's like you can't say, "Sorry, we can't communicate." So, oh, well, there's a different tower, pick up from over there. Or you've got an on-site radio source backed up by a distant remote off-site source somewhere else. I mean, to me, these are like, not the right word, light years, but it's a leap over just having a 2-hour rating of the building. And if you go to some of these events, and you hear about how some of the rules are, there might be, what if there's no building left? What if the antenna's dripping, puddle of plastic on the floor? Stuff like that. I mean, great, your 2-hour coax at, $10 a foot. Hey, it survived and the conduit survived and stuff like that. But uh, there's no building left, or the rest of the system isn't there either. It's just, I guess a word that comes into mind is common sense. There has to be a common sense approach by experts who drive the thought leadership in the industry to consider other things. It can't just be, whatever you want to call it, the old guard finding ways to cling on to doing it with old approaches, with old technology. That is counter to evolution in my mind.
And I'm wondering, Tom, if because we're talking about kind of like mission critical systems, and we also still have, I guess, the cookie cutter systems, and I
Hmm.
wonder if we're kind of at a point where maybe they're going to diverge. Because you think of schools, office buildings, I mean, things that obviously you need to keep safe. Maybe that would be more in the realm of kind of the cookie cutter, where when you're talking the mission critical, because here in Colorado, like where I live, I mean, we have two Air Force bases, an Army base, Cheyenne Mountain is here, where those would be mission critical. So maybe in those instances, yeah, they would want that diversity, they would want that redundancy.
Hmm.
But I wonder, like I was saying, I wonder if we'd be on these two paths, one that's, um, I don't know, everyday, I don't know what you would call that, everyday living or, what have you. And then these others that may or just maybe would be mission critical, like you're saying.
I get what you're saying, Gil. I guess there's different ways to look at that. Certainly makes sense the way you introduced it. To me, you also have other things in Colorado as well, like long tunnels and things like that that aren't conducive to just cascading BDAs as line amplifiers. But to me, I think my answer to your question, I support what you're saying, would be back to what I said earlier. It's just a toolbox analogy. You just need the right tool for the job. So if you have a small school, you can look at it differently, yes, because it's a school and because today's world is what it is. And it's an uncomfortable subject, but it is part of the news and part of today's reality. But not all schools are the same. If nobody, I'm not suggesting, I don't think anybody's suggesting, other than maybe reliability and redundancy. But if the facility, usually it starts with the facility. If the facility is of a certain size, the frequency band or bands is relatively simple. If all you need is a simple single BDA antenna on the roof, couple inside, there's nothing wrong with that as long as it's properly designed, the product, properly engineered, the solution, properly installed, properly tested. They do the right things in the uplink design, the coverage density, antenna density, etc. There's a place for that. If you're downtown and you're surrounded by 300 other buildings, then no, you're into other considerations. Maybe it's not the best answer. So it's an expression I think we all heard a week or so ago in a Safer Buildings meeting. It depends. So there's no one size answer in terms of the approach or the technology. So I do support your suggestion, though, that some facilities and some applications and even user groups are much more mission critical than others. And then you get into sort of the whole heart of the industry. Well, other than just putting more boxes in, what are we really trying to do here? We're trying to make it so that, police officers can respond in a certain type of facility in a certain type of event, which is far more common than really, as we know, where the rules emanate from historically, with the fire codes and stuff like that. So there's so many different layers of consideration, but I still think the way to look at it, until I guess could we use more rules? I don't know. Do we have too few, too many? Are they the right ones? Do they come for all the right reasons? That's a whole other discussion item. It's hard to say that you can't say any people are more important than other people. Can you say certain buildings? Yes, based on what goes on there is more important than just an office building. Nothing to do with the occupants or anything like that. I still think from the industry perspective, and again, being a manufacturer, it's just about anything that people work on and work with is just having the right tool for the job. It all starts with the requirements. It starts with the real world. What are we doing? It's not just here's a red box. Of course, how many can we sell? If it's a red box application with a BDA, carry on. If it's something different than that, don't just say, I got an answer. I'll sell you 20 or 50 BDAs and, things that were designed prior era for more simple applications, more simple world.
Fantastic. Perfect. Thank you. Thank you, Tom. It's been thoroughly enlightening. Thank you, Gil, for joining me today on this show. I think our guests are our tune-in guests are gonna love it, or should I say our listeners are gonna love it. You guys did a great job. Thank you very much, and have a good one.
Thanks, guys. Appreciate it.
Desk Talk by Gamma, keeping you connected and protected.